Here we go. We're doing only 6-3A, just half of it. We are on an assembly schedule, so I figured we only need to do half of it. The other stuff's going to take longer. Okay, we're going to talk about binomial. Let's start over. No. Binomial radical expressions. Now, you guys know what binomial is, right?
No.
2, yeah. It's when something has, no. It's when something has 2 terms in it, right? We had a monomial, that was 1. Mono means 1. Binomial, like bicycle, bilingual, that means 2. And trinomial was 3, like triangle, tricycle. A triceratops, remember? That was you, Kane. Yes. Oh, I talked about you last night, Kane. So we have just 2 parts today, very simple 2 parts. Here we go. Part A. We are going to first start by adding and subtracting. We're going to add and subtract like radicals. Like radicals. Like radicals. Not like that, but like radicals. I know. Okay, I sound like I'm from the valley. Oh, guys, that's too old for you. I'm not from the valley. Like, have you ever seen the movie Valley Girl? It's really old, way before your time. All right. White Chicks. No. Did they say like? It's your movie? That's it. That's it.
You've never seen White Chicks?
Is it good? Should I rent it?
You've never seen White Chicks?
No. No. No.
It's 2 guys and they dress up like these white girls.
Oh, no, I wouldn't watch that.
No, you would watch it.
You don't like when boys dress up like girls. Oh, already like, put those away. If they are already like radicals, then we can add them up. So for example, number 1, we're going to take 5 rad 3. We're going to add that to 2 rad 3. And yesterday we had a problem that we wanted to combine them. It was like 3 plus 3 rad 5, and we couldn't combine them because they weren't like terms. These are like radicals. I have 5 rad 3s, and I'm going to take 2 more rad 3s and add them together. So how many rad 3s do I have? I have quite a few, yes. To be exact, 7 of them.
So as long as you have the same rad, they're going to be like...
Exactly. You have to have the same rad and the same number inside the rad.
Yeah.
Yeah. Okay, so let's try another one, number 2. Let's do 7 4th root of 5 minus 3 4th root of 5. Okay, it works for adding. It also works for subtracting. As long as you have the same radical and radicand, that's the number inside, or variable, or expression, radicand, we can do this, then you can combine them. And what do you get? 4 4th root of 5. Perfect. You know how to write it though, right?
Yes.
Then that will count towards good points on your next quiz. Yes, Daniel.
So if it's not the same number, there's no way to like make it the same.
There is. We're going to get to that. We'll get there, don't worry. Okay. Try this last one, and then we'll move on to things that are not like already. 2 rad xy plus 9 rad xy. Okay? Those are good too. They both have a square root. They both have xy inside. We can combine them. There are 2 of them plus 9 more of them gives us 11 of them. Okay, so you feel pretty good. You don't want another one of those because then I would just be insulting you. So now let's go ahead to part B. And now what we need to do is, these are not going to look like terms, but they're actually, some of them are going to be. So you need to make sure that you simplify and then combine. Okay? Simplify and then combine. So here we go. Number 4. Suppose I have 5 rad 20 plus 3 rad 45. Now I look at those and I say, okay, they're both radicals, that's great, but they're not like radicals. The radicand is not the same. But neither one of those is simplified yet. They both have perfect squares in there that we got to get out, okay? So 20, what is a perfect square that goes into 20? 4. 4 times 5, right? Okay, so let's go ahead, take the square root of 4 And we get 2. What do we do to the 5 out here? We bring that 2 out. Multiply. So 2 times 5 is 10 rad 5. So 5 rad 20 is the same thing as 10 rad 5. If you don't believe me, watch. Your calculator even knows. 5 rad 20. What is that? Some gross number. And what did I say it's equal to? 10 rad 5. Same gross number. Okay? They're exactly the same. They're just written in different ways. Yeah. So here, this one, there's a perfect square in 45. What is it? 6 is not a perfect square. 9. 9 times 5. So take the square root of 9, which is 3. What's it going to do to the 3 out here? Multiplies. Good. And 9 rad 5. Okay, now look at them. Oh, they are like radicals. They didn't look like it, but they weren't simplified yet. So once you simplify, now combine them together. And how many rad 5s do we have? 19 of them. Okay, and that's your answer. I don't want any decimal answers here. We're doing all radicals. If you wanted to check your answer, if you're a little extra like that, you can go 5 rad 20 plus 3 rad 45. Okay, that's the original problem I gave you. It's equal to 42.48, blah, 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 blah. Well, let's find out if our answer is right. 19 rad 5, same ugly number. So if you ever wanted to check, like not for homework, you know, your homework you're just practicing, but maybe on a quiz and you want to get them all right, you can check them. All right, do you want to try one now? No. Okay, I'll do another one with you. Number 6, 5. I heard some shores. Yeah, not always. I wouldn't say always. I might try and trick you. I like to trick you. All right, 6 rad 18.
But you have to do the work before you can see if they will.
True. Yes, you do. That's exactly right. 4 rad 8 minus 3 rad 72. All right, so now there's 3 terms to combine. Right now, none of them look like radicals, so we need to simplify them, okay? Checking the schedule of what? The NHL? Oh, you want to check to see what time we get out of here? 11:20. Oh, we gotta move. Okay. The NHL schedule? What's that? Kings and Ducks tomorrow night. Go Kings, go. All right, here we go. Let's go ahead and simplify this. Rad 18. Perfect square in 18? 9. 9 times 2. You should be getting pretty quick at these, right? You getting used to them? Square root of 9 is 3. 3 times 6, that's 18 rad 2. All right, how about 8? Perfect square in 8? 4. 4 times 2. Take the square root of 4, which is 2, multiply it times the 4 on the outside, so that would be 8 rad 2.
Wait, say that again?
Take the square root of 4, which is 2, and then you bring it out, you multiply. There's a 4 out here, and then leave the rad 2 behind. Now 72 is a little tricky. If you go, oh, 72, that's divisible by 9. You are correct, but 8 still has a perfect square in it. So 72 has a bigger perfect square than 9. What is it? 36? Yeah, you guys are thinking, you were taking the square root already, huh? 36. 72 is 36 times 2. Okay? And the square root of 36 is 6. 6 times 3, 18 rad 2. Now, do you do this? Do you look at the whole thing and you go, oh, look at, there's an 18 rad 2 and a negative 18 rad 2. So those cancel each other out, and so your answer is just simply 8 rad 2. Yay. All right, you get to try one now. Boo. Number 6. You try this one. 2 rad 27 minus 5 rad 32 plus 6 rad 12. Okay, you do this one.
You change your 2's as well.
I do? Oh, yeah. That's so weird. Huh. That's funny. Go ahead and try that one. Yes. Right. Did you hear that? You can't add a square root and a cube root together. No matter what. No matter if their numbers are the same inside. You can't. Good call. I didn't even bring that up, did I? Oh, and you know what? I have one, and I skipped it. Ooh, the San Diego lottery is now open.
You're gonna drive to San Diego.
I would. I would totally drive.
Bro, what?
It's on pause. Oh, no, it's not. Oopsies. Okay. 27? Are you guys done?
No.
No. All right. All right, here we go.
You didn't say their name.
No. Square root of 9 is 3. 3 times 2 is 6. Rad 3. Okay, let's go to the next one. 32 is 16 times 2. Square root of 16 is 4. 4 times 5 is 20. Rad 2. Don't feel like you're getting that wrong. Not all of them can combine sometimes, and that's okay. And this one is 4 times 3. Square root of 4 is 2 times 6 is 12. Rad 3. Now what we want to do is we want to combine the ones that can combine together. So in this case, I have a 6 rad 3 and a 12 rad 3 give me 18 rad 3 minus 20 rad 2. And that would be your, you can't combine them, right? Okay, the question that we just had just a minute ago was, can you combine like a cube root of 7 plus a square root of 7? And no, you cannot. Okay, you can't combine those. Those don't combine. All right, I have one more for you, and that'll be it. Ooh, and we're almost out of time. Number 7. 2 times the cube root of 16x cubed plus 5 times the cube root of 54x cubed. Excuse me. Okay, so now we have to switch gears in our head. We're not doing perfect squares anymore. We're doing perfect cubes now. So what perfect cube, because there is one, will go into 16? 8. We wrote our perfect cubes down the other day on that paper. If you need to look at them as you go along, that's okay. So this is 8 times 2. So let's do the number part first. So let's take the cube root of 8, which is 2. I'm going to bring that outside and multiply it. And I'm going to leave that 3 behind. Sorry, it's not a 3. What is it? A 2. Then I'm going to look at this x cubed right here. 3 goes into that 3 how many times? 1 time. No remainders left. Okay, so that's completely simplified. And I'm going to add that to this one over here. So, do you know any perfect cubes in 54? 27. 27 times 2. Cube root of 27 is 3. 3 times 5 is 15. Leave that 2 behind. Same thing. 3 goes into that 3 of the x 1 time. And now we have exactly like terms. We have 4 x cube root 2's and we have 15 x cube root 2's. So how many total do we have? 19 x cube root 2's. You're right, I do write my 2's down.